All right, good morning, everybody. This is the second session on the integration timeline today, March 18th in TechCon 2025. Today I'm joined by Rob Convery and Ben Thompson, and they're going to cover App Connect Enterprise in containers and streamlining DevOps. And they're also going to look into deploying ACE and Kubernetes, best practices for that, how to optimize performance, and automating your CI/CD workflows. So if you have questions, please put them in the chat and we'll deal with them as they come through if we can. And if not, there's an office hours later today where we'll answer those questions we didn't answer. And if you, as I did in the last session, you think about questions during the day, then come back for the office hours and ask then and we'll deal with it. So with that, I'll hand over to Rob, who's going to walk us through App Connect Enterprise in containers. Okay, take it away, Rob.
Hi, thanks very much. Yes, so I'm going to give an overview of App Connect, how we've transitioned it into using containers, some of the technologies that we're using, and then I'll be handing over to Ben, who's going to go through some of the pipeline aspects of that. So we just think about containers, thinking about it from an ACE perspective. Many of our customers, they will have potentially transitioned from those physical machines into VMs, and they've started to take that modernization route, and really containerization is the next evolution of that, where you might have started with your really big AIX server, 32 cores. You've now broken that down into VMs so that you've got 4 cores in each VMs, a number of runtimes deployed to it. This is that next evolution. This is now, instead of having 4 cores, you might just have 1 core, you might even have half a core or even less. And you want to create a bespoke containerized instance of that application or group of applications and tune that in a way that can be very specific to that unit of work. In the VM world, it's very much a pet. It's something that you start, you create, and then over time you'll add configuration to it. Some of that may be automated. It may be by manual interaction with the cluster, and over time it will be built up to be the workload that you desire. Comparing that to the containers, with the containers you're typically working on a smaller set of artifacts, and you want to be able to get that as a repeatable object, so that if there's a problem, you can restart it, it keeps going. But that does have other things that you need to think about. For example, if you are now starting to break that down, what we'd often do in the VM world or the physical world is, on a given machine, you typically would deploy lots of configuration for all the various flows. So you might have all your DB2 configuration, or your Oracle configuration, or your JDBC configuration. All of that is configured in your VM, meaning that anyone can bring along the flow that they desire and it will work. But moving to containers, we don't want to take the burden of configuration that we don't want to carry, because the smaller you can make the container, the quicker it will start, the quicker it will work. So it's all about taking the next evolution of your VM and making it into a smaller unit of work that gives you that repeatability to use. And then you can start realizing, actually, these are really simple things to use. I can spin one up, I can test against it, I can shut it down. If it crashes, another one will automatically spin up to replace it. That does have implications. Obviously, if you have containers that are potentially being shut down as the cluster is being updated and a new container is coming up, you need to make sure that your flows can tolerate that. So there is a bit of adjustment, not just in terms of how you package your flows. You do have to think about it from a whole architectural aspect, because you should really be able to tolerate your container at any point in time, restarting and coming back. So that's where, if you do have a stateful integration server, making sure that that state is maintained and the new servers come up in the right sequence. For example, if you have some sequencing nodes, or other runtimes can equally just carry on the workload. So really it is just about taking that larger VM, bring it into a much smaller thing that you can then start to get running. But of course, the question is why do we want to do that? What's the benefits of doing that? And it's all really part of that agile thinking. Being able to respond quickly to those requests. How do you respond quickly? Part of that is by having consistency in terms of how we test things, the reliability of knowing I've tested it in this environment, I can move it to the next environment. It's the same thing. With containers, that's what you get. You can have a container you pull straight through your pipeline, you run it in unit tests, you run it in system tests, you run it in your pre-prod environment. You can have the same object going all the way through the same images, and you get confidence in the product as it goes through your pipeline. And then as you've got that, you've got your declarative pipeline. So everything is in a known state. And it gives you the opportunity to then quickly test changes. If you have someone that comes in with a new request for enhancement, you've got the pipeline to be able to deliver that to your customers quickly and easily, rather than having to go through the traditional manual mechanisms. So there's lots of benefits from going to that containerized architecture. But thinking a bit more about ACE, let's talk about the factors that we now have in ACE. And of course, at the bottom of this stack, we've got ACE, tried and tested. I think we're approaching the 25th anniversary. There is some debate over whether it's this year, last year, or next year, the official 25th birthday, but it's very mature, very reliable, and used throughout the world already. And when we wanted to move that in containers, obviously the key aspect is maintaining that core ACE software. So everything we do really is based around that integration server. It's the process that runs your business, and we need to maintain that as being the same thing you're running in both ACE software and when we move it into containers. So that's where we'll talk about the operator and the orchestration that provides above that. But within our product itself, we've obviously got our ACE as a service offering. And to make sure that we're building on what we produce, our ACE as a service offering uses our ACC operator, which in turn uses the ACE software. So we're using our own offerings within the capabilities that we're selling to the customers. And that's great because it gives us the chance to prove out and show that the products that we are shipping are suitable for large scale deployments. So as a very high level number, for example, when we're running in our SaaS, we know that our operator, for example, can reconcile 1,000 integration runtimes. There are certain configurations we need to do that, but we know we've achieved that and we've seen it proven in a real world environment. So that gives us confidence throughout the stack. We've got confidence going up because we know we're built on tried and tested software, but then we're also gaining knowledge on knowing that we're testing the middle layers that are then used in the upper layers. So it really is a case of building on the reliable software that we've always had within App Connect. And of course, as we add features, ideally we add them to the ACE software at the lowest level, and then we can get the benefit of those throughout the whole stack. Sometimes we require some extra work to get it working in a containerized environment. Sometimes it can work straight out of the box. New connectors, for example, we produce those in ACE. We'll just pick those up as we pick up the ACE latest versions in the containers. So it really is about building on top of our offerings on top of each other. So if we think about what the operator is and what does it do, what is the purpose of it, it really is about helping customers take their integrations and move them into a Kubernetes containerized environment in a simple way. We want to make the object of getting from the VMs or from your on-prem machines into containers as painless as possible, and let the operator worry about doing all the complicated stuff and getting it configured. And the operator does this by providing custom resources in Kubernetes. So these are CRDs that you can then create your own custom resource of, to then create various components that I'll talk about. And that's key. It's creating resources in your Kubernetes cluster that are just like any other resource. So the same in concept as a deployment or a stateful set. And by doing that, it means we can take advantage of all of the great tools that are out in the public domain for orchestrating those things. So where you might have some orchestration around a deployment, let's say, you can update that orchestration easily and freely to use our operands that we use for the operator, so our integration runtime. And it just slots in. It's just another CR. It's a YAML definition for that resource. And by doing it through the native Kubernetes interface, it means that all the tools that you could use previously, you can continue to use to do your orchestration. And Ben will be demoing a couple of those that we've used to do that orchestration around the runtimes. So in terms of the actual resources that we provide in the operator, the key one is our integration runtime custom resource. And this is the runtime that really inside that is your integration server. That's the one that will be running your business and performing all of your message translation or your message processing. When you create your integration runtime, the job of that operator is to then go and create all the various resources in Kubernetes you require. So that might be some deployments, some pods, some services, such that you as a user, you don't need to worry about the orchestration of the Kubernetes environment. You just need to define what runtimes you would like to run, what flows you would like to run in those runtimes, and then it's the operator's job to make that happen, make them available, and make them online for your customers to use. We also have configurations as a resource that we create, and I'll talk about those in a few moments because they're really critical to how it works. And then in addition to that, we also have a couple of UIs. So we have our App Connect dashboard, which is very similar to the web UI, but it provides a slightly higher view. So it shows you a view of all of your runtimes within a given namespace. Very similar to the App Connect dashboard, you can also get in software where you can add integration servers and integration nodes and provide that overall view. In containers, it's the same software, but we're showing extra things like, for example, it's aware of replicas. And then we have our designer interface, which is our no-code authoring experience, which again we'll touch on as we go through this presentation. So in terms of the actual operator itself and using it, installing it, the most crucial questions, of course, are what can I deploy it on? How long will I be supported? And we have two environments we support. We support OpenShift, essentially on any provider that you wish. So that might be on Azure, on IBM Cloud. OpenShift provides us essentially that orchestration layer above the Kubernetes, and it doesn't matter what provider it's on. If it's running OpenShift, we'll support it. We support versions from 4.12 all to up to 4.18. We try and keep that maintenance within 30 days of OpenShift releasing a new version. We'll try to get it into support in both of our offerings and make that available to you. We typically would only remove a version once OpenShift brings it out of support. So for example, originally OpenShift 4.12, it was going out of support in last December. They decided to extend that support offering for another year, so it doesn't go out of support until December 2025 now. And as a result, we have also updated our support statement to reflect that. So we continue to support 4.12, and you can raise all of your support tickets and they'll all be serviced. So you can get great confidence with that. If you don't have OpenShift, of course, we do still support bare Kubernetes. This uses Helm to install the actual product. About 3 or 4 months ago, we did switch from using OLM to using Helm. This was as a result of feedback from our customers that they much prefer the Helm software and use cases and integration in the Kubernetes environment. So as a result of that feedback, we've switched our implementation to use Helm, which also aligns with some of the other products within the IBM portfolio. And the versions of Kubernetes that we support are essentially aligned with OpenShift. So 1.27 is the version of Kubernetes that underpins 4.12, and equally 1.31, which is our top end, is what's underpinning 4.18. So there, as we add a new OpenShift, we will also add a new Kubernetes, which is what's providing the underlying support. So again, they're typically moving up at I think about 4 or 5 month schedule that they're releasing new versions, and we'll be releasing them as they're added into the OpenShift environment. Now, coming to the streams, this is where it gets really interesting. We've got 2 streams. We have what's called our SC2. It's a support cycle for 2 years. So we GA'd that in June 2024, and it will be in service until June 2026. It's based very much on our V12 stream. Another term often will be used to refer to this is our LTS. So it's really about just getting long-term service with very minimal changes. We only ship bug fixes and security updates in that environment, but we are still doing monthly updates for that. So we're continually providing the security updates, making sure all the images are updated. We've picked up all those security updates, but there's no features whatsoever delivered to that stream. So if you're happy with the feature set, SC2 is a brilliant one to go to. But alternatively, if you want to start looking at some of the newer capability that we're bringing out, or for example, wanting to start going onto the ACE v13 stream, then you can start to look at the CD stream. And that's a case of a continual updating stream. We're picking up the latest version 13 releases as they come out. Every month we're picking up a fix pack, and then every 3 months we're picking up the ACE mod pack releases. So again, we're doing that monthly cycle, but the key difference is there we are picking up new features versus the SC2 where we're not getting the feature updates. One thing, other comment around the SC2, typically I've said there we have, for example, our 2-year life cycle. Whenever we would bring out a new major release of our SC2 stream, it would typically have at least 6 months overlap. So that would indicate that there may be a new one coming approximately at the end of this year. We would have a new long-term release, allowing a time to migrate from one release to the next. In terms of differences between the OpenShift and Operator, actually it's not a lot. It's all common code. It's code toggles in there rather than an actual different offering. So it's all built consistently, depending on no matter whether you're on Kubernetes or OpenShift. But there's the main couple of differences are in Kubernetes, Ingress, of course, is not standardized completely. There are many common attributes to it, but each provider often has its own annotations or slightly different fields that it needs to work correctly. And as a result of that, we don't support all of the various myriad of Ingress platforms that are coming out. So what we do is we create the service within the operator and then allow the customers to create the Ingress resources for their given platform. That said, we are just actually in the middle of GAing a new capability around Ingress. So if you're running on IBM Kubernetes service, there is now the capability on most of the operands. The final one is coming hopefully soon, whereby you can create Ingress out the box by just telling us in the CR that you want to use Ingress. And then just like in OpenShift, you will get your resource created, and at the end of it, you'll get a URL that either will be your runtime or your UI to go to. We also, because we're not part of CP4I in a Kubernetes environment, we don't have the tight integration with API Connect that we offer. Other than that, it really is just as good. And as I say, it's all the offerings are equivalent over the two. Of course, full air gap support. So we support that in both Kubernetes and OpenShift. And then we have a support page that actually details the various versions of ACE that are available in each operator release, and what, for example, MQ client we use, and all the various aspects of those releases. So really good document that's worth watching. So this is just a quick chart to go over the layout, and really it's just confirming what I've described before, how in software we've got our integration server. When you move into containers, that becomes your integration runtime resource, but it's built on the integration server. We've got our ACE dashboard in software. We've taken that software, we've enhanced it, we've added it into the containerized offering, but we've also bolted on an extra capability of a content server such that you can upload your bar files. We've got the operator itself, then we have this new designer authoring experience, and then the toolkit. Obviously, if you've designed flows for your software, you can use that same toolkit for designing the flows for your containerized environment. And all of that gets packaged up and is part of the App Connect offering if you'd like to move to Cloud Platform integration. So it's all, again, it's building up on top of it. Now, configurations, this really is where one of the most important capabilities that the operator provides. When you're running in Kubernetes, you can either be stateful and require persistence, or you can be stateless, and then that provides you a lot more freedom, a lot more flexibility of your design. And as a result of that, ACE as a product, we've gone with the stateless scenario. So as a rule, when you create your runtime, it's a stateless object, and we load in all the configuration on startup via various Kubernetes resources. And this is where the operator provides a configuration CR. And that is there really to take in all of the parameters that you use to configure ACE. As we know, ACE has been around for a long time, but there are lots of different things and lots of different ways you can configure it. You have policies for configuring certain aspects. You might be interacting with your databases. So you've got an ODBC&E, a DB2 CLI that you need to edit, but you've got credentials. So you've got your vault. You might have some certificates for the endpoints that you're talking to. All of those parameters, all those things that normally you would just go and you deploy them to your VM. We now need to take those and put them in Kubernetes so that whenever your container spins up, we can load them in on the fly and get that running. And that's where the operator is involved. It takes all those various aspects, certain ones of those, it will do a certain amount of validation on them when you're creating them, and then they'll be able to configure those into the runtime for you. So I've talked about really how it works. Really, this is just a little example of some of the things that we've been working on recently. One of the big changes we had recently was Keycloak. So we used to use foundational services. It had an IAM capability in it, but unfortunately that became deprecated. So then we had to look for a new offering. And for that, we now have centralized on Keycloak for providing our IAM for both our dashboard and our designer. And that decision, that was actually aligned across the CP portfolio. So all of the products, we've all gone for Keycloak as that centralized tool for providing the IAM. So our dashboard and our designer interfaces into Keycloak, and then Keycloak can interface to your various identity providers. And that enables you to have that one Keycloak instance configured, and then not just App Connect use it, but potentially the Cloud Platform integration, the Platform Navigator, or API Connect. So that's been a big change that came in towards the end of last year. But we're continuing to do things like, for example, we're seeing a lot more people now actually using images that have bar files baked into them. And as a result of that, they don't use the dashboard capability where you can upload files. As a result of that, we've added an option to make sure that you can actually tell us, I don't want to store my bar files. And that means we don't need to load an extra container designed for storing bar files. It makes it more efficient, more CPU efficient for running those containers. Things like I've talked about the open out-of-the-box support for Ingress and Kubernetes service. If you're looking at using App Connect and you're not looking at IBM Kubernetes service, please do let us know which platforms you are looking to use. The most popular ones are the ones that will drive our decisions on where we might add support to next, whether that's Azure, AWS. So the next step would be support for another platform. Which one it will be really just depend on the feedback that we get. Another one, for example, taints and tolerances. This is a mechanism for putting all of your workload in one or two or more workers within your cluster. Licensing works such that you can either license your container, or you can license a certain set of workers and make sure all of your ACE workload goes onto those workers. And there are different topologies you can deploy depending on which choice you make. And we've added the support for taints, tolerances, node selectors that make sure that if you do node licensing for ACE, you can make sure that only those ACE runtimes are put onto that worker, and we don't get polluted with other runtimes using up the CPU, which we've used on ACE licensing. Now on to the next one, which is all around the converged runtime, a term that you may have heard in a few talks that we've been doing recently. Converged runtime, single runtime. We really mean the ACE runtime, but converged is the term that we've often been talking about. And this is all around, if you think about the authoring experience that we've had for a number of years, we've had our toolkit. The toolkit can deploy to the ACE integration server. Everything works brilliantly. In the cloud, a number of years ago, we brought out our designer, our no-code authoring experience. And that originally could only deploy to cloud. As we've moved that into containers, we've brought the authoring experience into containers, and we also brought in the runtime that processed those messages. So on the picture on the right here, what you can see here is when you deploy a toolkit developed artifact, we would deploy that into the integration server container within your integration runtime. If you deploy a designer authored flow, what you would actually get is a couple of extra containers, and those would be used for processing those flows. So that was because we've developed different things in different places, and we're trying to converge them down into a single runtime. So from a user's point of view, you did just have one thing. You had a bar file. It could come from the toolkit. It could come from designer. You would deploy it, and we would make sure we got that running for you. But depending on what it was, would dictate where it went. Now, if we look to the picture on the left, what that's starting to show is as of version 13 of ACE, it now has that designer authoring experience built into the ACE software. So now the ACE integration server now knows about these designer flows. So what we're now doing is the containers in the middle are starting to convert all of those flows that you're running in design or developing in designer, and we're taking those, and instead of creating those extra containers, we're deploying them straight into ACE. So again, we're taking the work that we've done in the ACE software and we're pulling that into containers, such that as the connectors that are being developed are put into ACE, when they're available, if your designer flow is supported, if you, for example, got a Cloudant node and a Salesforce node, if they are supported in the ACE runtime, the operator will look at that flow and say, yes, ACE can run that. So it will go and create that flow purely in ACE. If we find that there's a connector or a capability that's not supported, we will still deploy that old format. Obviously, we're working our way to have the end goal of being that middle picture where everything you run is just in the integration server, whether you deploy it in your toolkit or in designer. Now, I've talked a lot about the operator, and that's where if you're developing with the operator, you might find that actually we don't support absolutely everything that you might need to do. For example, you might have some libraries or some extra files that you want to make sure they're in the image from the very start. And that's where you can start to then bake extra files into our images. And that's where this ACE server prod image gets involved. It's used by our operator out of the box, but we fully support customers taking that image, adding extra files into that container that required for the ACE operation, and then referencing it in their CR. And that allows them to then run the extra capability that may not be supported in the operator. As I say, we're trying to make sure the operator can do as much as possible. So then the reasons to do that code is getting smaller, but there's always scenarios and use cases that sometimes require that, and it's fully supported. But that image is really designed for our App Connect operator. It's got lots of tools, lots of mechanisms for moving data around, changing the formats of things, updating your server.conf.yaml, and they're designed with the operator in mind. They're designed to go tightly with the operator. Sometimes we optimize that code and change how it works. And as a result of that, we don't recommend using that for your own deployment. So if you're doing your own deployment, you shouldn't use a server prod images, because they may change, their behavior might change, because it's designed to use the operator. But we still want to help our customers in that scenario. So we've also got our ACE image. And this really is about giving the customers who want to do self-orchestration, they want to take that image, they want to do all the various orchestration, which is perfectly acceptable. We have the range of customers. Some want them to do everything themselves. Others would like to hand more of that responsibility to IBM and use the operator. But that image provides essentially the ACE binaries in an image that you can then configure in your pipeline. And what this means is, rather than having to do the manual access of accessing Passport Advantage, downloading your binaries, putting them into your repository to then build into your image, the start of your pipeline can be just a simple image. You can then just change a reference on it to pick up the next fix pack or mod release, and then it will get built up using that. So it's a simpler image, but it's also supported on a much wider range of platforms, for example, because it really is just ACE. The key thing is it can near enough run in most platforms, because it's just a case of how you run your container in that environment. And at that point, I'm going to stop talking and then start handing it over to Ben, who is going to talk around some of the pipeline work.
Thank you, Rob. So if we've done the handover successfully, you should now be seeing a new screen, which is entitled Remote Code Deployment. And in my section of today's talk, we're going to be talking about the theory of how you can take everything that Rob was talking about there in ACE-certified containers and create a pipeline around it. So we're going to talk about some of the concepts and a couple of charts first, and then we're going to dive into a real-life example, which is going to be a demonstration that I'm going to play via video. So it's the best kind of demonstration. It's one that we know is going to be successful, and hopefully it's going to finish on time too. So what have I got shown here? A remote code deployment style, which we sometimes refer to as frying. And that's a cooking term, basically meaning you take all your configuration and code and then push it into a pre-developed ACE-certified container image, which has got the core binaries already laid down in a sensible way on the disk system. So if we think about the different stages that are involved here, we first of all extract code from your source code management system. Maybe it's GitHub, maybe it's something else. And then we build from that code, the message flows, the message models, any ancillary code. We build from that a package, a bar file as we call it. And that bar file can then be placed into your own repository. It could go into Artifactory, for example. It might go into GitHub itself. And then that bar file can then be referenced from your Kubernetes installation. So step 3 here is to then apply some changes through our control plane, part of what's provided as part of the ACE-certified container product, which takes the image from your container registry, which has the core binaries involved, the one that we've already built with ACE installed inside it, and then lays your own code on top of that. And that process of frying in the bar file content, taking in the configuration that Rob has been talking about, and spinning up the number of desired replicas is essentially the pipeline that's built into the product. It's what you get by getting hold of ACE-certified containers. And if we compare and contrast that, then of course you may have your own preferences for what we call baking. And baking is a little bit different. It still involves taking your own code and laying it on top of an ACE server. But it's also involving the reformulation of new containers in your own registry that have the same core layers involved. And Rob was just talking about how you could build those from an ACE-certified container and starting from that image, but then putting your own content on top of that. And so this diagram is a little bit different. Instead of independently building a bar file and then putting that bar file in at the last minute, instead, much earlier in the pipeline, we're putting the bar file content on top of the core ACE-certified container, and we're building a new container that's got those new extra layers on top of it, and we're storing that away in the registry, which from where it can then be pulled and started very rapidly. So for those wanting the absolute quickest and shortest start times, you might want to consider the baking mechanism. Now, as usual, when you present 2 ways of doing things, the natural question is, well, what are the pros and cons? Why would I choose one over the other? And the astute amongst us will notice there are actually 3 rows in this table. And the reason for that is I've also put on here the classic enterprise service bus pattern, where you might deploy into an existing environment that's already been built. And so really, if we like a manifesto for why containers are, quote, better than live server deployments, that's really what the first row in this table is trying to summarize. So if we focus our attention really more on the 2 different styles that I just described, the remote code deployment or the frying versus the baked code deployment, you can see the pros and cons here. And maybe if I just pick up on one in the interest of time, you can see that if you're doing remote code deployment, you are at the mercy of the site that's then hosting those bar files. So that's an additional point of failure that you might need to consider in terms of your high availability or disaster recovery. Now, in many cases, the chance of the site going down that actually hosts those images or those bar files, it's relatively small in the grand scheme of things. So not a huge con, but maybe worthy of some thought there. I think the other aspect on this is often the skills that you've got in order to deploy. So if you're just getting up and running with containers for the first time, if you haven't yet learned a lot about the ACE operator, then perhaps using that method of frying that comes out of the box with our operator, with our dashboard, with the UX tools that we provide you, that might be an easier way for you to get started with the product before perhaps progressing when you've built some stronger pipeline skills, progressing ahead with the baked deployment style perhaps a little bit later. Now, alternatively, if you're already experienced with containers in other contexts outside of ACE, perhaps you'd go straight for the baking one. And that nicely leads us on to that topic. How can you create those pipelines? There's lots of technologies out there, and where possible, ACE remains agnostic about different tech choices. But in this case, we're going to be talking about one that's already available as part of your OpenShift platform. So there's a technology called TechCon, which has then been productized in the Red Hat OpenShift platform as our pipeline technology. And this chart is really a quick summary of the pipeline that we're about to show. So the pipeline's broken down into separate discrete tasks, and each one of those tasks can be linked into several steps. And those steps can be executed in build terms when this pipeline is running in different containers. So we're actually using containers here in order to run a pipeline technology for building containers. And so alongside that, there are some requirements. If you want to share data between these different steps in your pipeline, you might need to set up some workspaces that mount persistent volumes in order to share disk systems between them. You might have other things in common, like Kubernetes secrets that you might want to store. So if you're building something that's part of the pipeline that requires a secure identity, you might want to go after secrets for that. And of course, linking into a container registry, because we're running these steps in containers, you're going to need some images in order to grab from that container registry in order to spin up your pipeline. And we don't have time today to go into all of the nitty-gritty of the various pipeline steps of the one that we're going to demonstrate. So I just thought I'd put up one chart here that kind of describes the concept of what we were just saying. So here we've got an example of a pipeline artifact, and it's split up into the 3 different tasks that are shown in the red and the green boxes on the right-hand side. And each of those task definitions can refer to reusable tasks. Some of those might be ones that you've created yourself, and others might be already available. So, for example, if you're doing a clone from GitHub, which is one of the tasks we'll be doing, we need a pre-created task for that one. It avoids us having to write it ourselves. We can also specify the order of each of these tasks, and we can run them in a specific order so that either everything runs in parallel or you can run everything in series. And that's particularly important when we think about our example pipeline that I'm going to show a picture of here, because there are some stages we want to happen in each of those ways. So what we're going to do here is we're going to push some code changes into GitHub, and that's going to trigger an OpenShift pipeline using a Git webhook. And that pipeline's responsibility is to build a bar file in the first instance that we're then going to push into a different repository on GitHub called ACE bars. And having done that, we're then going to deploy that bar file into 3 separate environments. We've got our public cloud environment that we were introducing earlier called ACE as a service. We have a local certified container environment running on OpenShift alongside the pipeline. And then we've got a traditional ACE software deployment on premise. And we're going to do those 3 pushes in steps 4, 5, and 6 all at the same time. And as luck would have it, when you run a pipeline, you also get a lovely sort of visualization of what's happening here. Now, the particular pipeline that we're going to run on our recorded video in a moment takes just over a minute to execute. So we've sped that up here just for the sake of the PowerPoint to show the various stages involved. And we've got 3 separate stages to begin with: that cloning of a repository, the building of the bar file and then the pushing of the bar file into the secondary repository, that has to execute, and that's in common across all three of the form factors that we're ultimately sending the data into. So ultimately then the push happens to all three places and everybody gets the advantage of the same update. So far so simple. What kind of scenario are we going to use with this pipeline? Well, I want you to all for a moment just to think that you're the purveyors of a coffee website. Imagine that this coffee website allows you to buy a quantity of coffee of a particular strength. And in a way, we can just say, look, ignore the content of the data that we've got in front of us here. It's an excuse to be able to show you something running in multiple places. So if you're going to focus your attention on anything here, the important thing is to look at the host name on which these messages have been executed, the software version, and then the flow version. And I'm going to be talking about those three aspects when we spin through the video in just a moment. Aside from that, the basic concept here is that you're going to make a call from this website into App Connect Enterprise, and you're going to query the inventory to see what you've got in stock. And we're going to have a certain amount that we're asking for and a strength. And sometimes we'll be lucky and there'll be enough coffee, and sometimes we'll be unlucky and we'll get an error message saying we don't have enough in stock. But regardless of that, the really important thing to note is where is this stuff running? So what we're going to have running here is those three environments we spoke about. And pre-wired before the demonstration executes, we're lucky enough that we've actually got them already connected up together, and we've used a switch technology in order to do that. And that's just detail as far as this demonstration is concerned. So the red circles here are showing how these different flows are linked together. And in each one of these three environments, we've got a couple of message flows that are running. And each of them has what's called a callable flow inside of it. And this can be set up to choose to either make a local call or to make a remote call. And to begin with, when we start the video, we're going to be using local calls. Then we're going to make a change in order to make it a remote call. And when that data then flies through, you can see here in the example of the local case, everything is executing just in one place on premise. Whereas if we move to the remote call case, when the data comes through with the flashing green boxes, it then jumps to a different system. In this case, we went from on-premise and then we ended up executing on OpenShift. And that's reflected with the values that we're then going to see inside of the data. I'm going to leave this chart at this point and we're going to go straight into the demo. And in order to do that, I'm going to bring up the recording, and as it plays, I'll commentate over what's happening on screen. So we've got, in a moment, we're going to see these colorful screens that show data actually going through. But before we get to those screens, we're just going to have a quick sneak peek on a few of these different web browser tabs to look at the context that we've got. So here we can see a few pipelines, and the last one has executed previously. So we're joining this system as a pipeline has previously already deployed our solution. And we're going to make a change and update that deployed solution in just a moment. And then as the pipeline executes, it takes around about a minute to go from beginning to end. We're also going to be interacting with the toolkit, and the toolkit actually has built into it an interaction with a GitHub plugin. So the GitHub plugin is going to enable us to push to remote GitHub to update an artifact and then to make the development change. But before we do any of that, we're actually going to start by sending some data into the system. And you can see on the screen here, I've got three different colored windows. The top one, colored in blue, is designed to represent the cloud, the sky, blue for sky. And you can see that we've just sent some data in there to our public cloud system, asking for 100 units of coffee. And the response has come back and it shows that it's executed on that same platform. So you'll notice the host name where the mouse is highlighting the host name. That starts IR01. That's the same as the domain name that we actually curled when we sent the data into the system. So this is an example where the data is coming back from the same system that we originally invoked it upon. You'll also note that the software version when this demo was created, this actually dates from last June, so it's a little bit out of date now, but it shows that the version is 12.0.12.2, and then the flow is at version number 1. Now I can repeat that same query, and unsurprisingly, the same query goes to the same local system, and then it gives the same response back. So all this is proving at the moment is that when we're using local callable flows, everything executes in one place and one place alone. Now, if we compare that to what's going to happen in the next window, we can see what the difference is when we invoke a different system. And you can see here we've got some variety of data. So we just tried for 500 units of coffee and we got an error message back. But again, it's all executed by that same local system. That's all executing in the public cloud. Now, if we switch to the second window, in the green one here, this green one represents the Earth, the middle section. This one is our container platform. And you'll notice here that the URL has the word Sissinghurst in it. That's a team that I work in, and that's our way of identifying this particular container platform. So the green one is representing data being sent into OpenShift. And you can see here now that the host name is different to what we did in the blue text. Here it's executing in a different system, therefore the software version is different. So this is slightly back level. So I've got a slightly older system here with 12.0.11.1 running in containers in OpenShift. And then I've still got the same version of the flow deployed. So flow version 1 is deployed in each of these different locations. Finally, before we actually run our pipeline, I can see here the last of these, and this is looking at an on-premise system. It was actually running on my laptop. So my local host name in Hursley has got the IBM address that you can see there. And again, the response has come back from that same name, from the host name IBM-PF3V and so on. And if I hit it multiple times, each one of these is coming back from exactly the same place. So far, so boring. We've got slightly different versions of software in each of the 3 environments, and each of them responding just locally, having invoked that callable flow. So the next thing that we're going to do is actually switch our environment around now and actually execute the pipeline. And I'm going to use a couple of different windows to do that at the same time. So we're going to focus first of all on our toolkit, where we're going to make a very quick development change. And this development change is essentially going to be changing the version of the flow so that when we go and look at it in some of our analysis tools, when we look at it in our UXs, we'll be able to clearly see that it's been updated. So we're changing this to be version 2 of the flow rather than version 1 of the flow. And then the only other thing that we're going to alter about these flows is whether or not we need to invoke that callable flow locally or remotely. And that's done with the callable flow invoke node. And you can see at the moment that the call preference shown at the base of the screen is being changed from preferring local calls to doing remote calls. Now those changes are going to get saved, and then we will need to push them into GitHub. So if I change perspective here into the GitHub perspective, we can see that it's got some unstaged changes. I'm choosing to promote these to push them up into GitHub to create a pull request. And I'm going to apply a commit message as part of making that update. So again, it's just a very simple message. It says apply v2. And in a moment, when I click go, the reason why I've moved the window across there is to show that what's happening in the background is that's immediately going to trigger our pipeline. So the push takes a few seconds. We get a confirmation pop-up that will appear back in the toolkit. There it is. And then in the background, you'll see the color change from green to be blue. The pipeline is now running. If I change the focus of the window, you can see that it's now executing. And if we click into that individual pipeline run, we can see the diagram that we showed just a moment ago in the PowerPoint. So this is running the pipeline in real time. So you're going to have me pad for around about a minute as it runs from beginning to end here. And the purpose is to divide it up into these 3 different stages and then push the update into each of the environments. So once we've got the update deployed into each of those different environments, the next thing that we're going to do is then go and check that it's genuinely been updated. And we can do that by bringing up various different consoles in our web browser tabs in order to connect those sessions and ensure that they're now showing as running at v2. So there it goes to 8 on OpenShift. It's done the local one first, as you might expect. And then the little rotating symbols of doom there, they're showing it's gone to on-premise and also the public cloud. So everything's run. The pipeline's been successful. And now we're going to see some of the impacts of that pipeline. So if we switch up, we can then go and see what the actual pipeline is executed. The first thing that it did is actually to pull down the source from GitHub and then rebuild that into a bar file. And if we see here, what we've actually done is we've applied v2. So that apply v2 message that you can see in the top line of Git, that was what I did inside my toolkit. That was the commit message that went when I did the push. And that happened about a minute ago. And you can see there that the individual files that were updated included the .message flow files. There was 2 of them, in fact. There was the one that did the callable flow invoke and then the one that reacted to it. So all of that was the push that I did from my toolkit. The second place we can see an update is in GitHub, where we pushed the bar file that we built in that pipeline. And again, we can see that it happened 1 minute ago in the last but 1 line. I would say it has an up-to-date timestamp, but again, this is showing the dates from last June when we created this demo. If you compare it to the timestamp in the bottom right corner, you'll notice that there was a 1-hour difference between GMT time and my local time when I created this back in the summer. So that was an up-to-date update that happened into GitHub. And the last thing to check on here is if we then do a refresh in these various consoles, this one's looking at my local node. I can dig down here into that server and I can click on a particular flow. And if we do a search here on the version name, we can see that's been updated to version 2. So that's the localized implementation on the integration node that's been updated. And again, if we go to a different one of the web browser links here, this is showing our public cloud dashboard. This particular one was running in the London region. And if we dig into the server, we can go to an individual flow level. We can look at what that's got associated with it in terms of a version. So go right down into the local flow. We're going to scroll down to the bottom of the screen or do a search here for version 2, and we can find that that's been updated as well. So we're confident that everything has been updated. Now, having done that development change, we're then going to see the impact of that, and we're going to view it in different environments here. So we're just doing some clear screens in each of those 3 terminals that we were interacting with just before. So I can see now we are just going to bring this in on schedule, so never fear, we've got 2 minutes still to run on this before we end up our time, so we'll be just on time today. And the first one of these is issuing a curl request again. It's going to the local environment in ACE certified containers, but the response message has actually come back from my local on-prem hostname. We can highlight it there. Now we've got a different hostname that's replied to the one where we were actually doing the invocation. So this is showing that having updated it to version 2, and again, you can see flow version 2 is now being carried in the data as well. Having made that update, now we're going to a different location. And having repeated the update, not only are we going somewhere different, but it's now changed a second time around. And this is exhibiting one of the key behaviors of callable flows, that you can do round robining between lots of different environments. So this is really showing that you can deploy once, but deploy anywhere and run anywhere, and then have that automatically cycle between those available environments. So handy to be able to do that, and again, shown by invoking that middle prompt first. And essentially, we see the same behavior in all 3 of these different environments. So regardless of whether we make the invocation to containers, or in this case, the public cloud, the one that's being highlighted here, we're still getting the response that could come back from any one of the 3 environments. So regardless of where we invoke it, we're still seeing the same behavior come back from each of those environments. So at that point, I'm just going to leave the video just to give us enough time today to wrap up. So if I just switch my presentation mode back to the calendar, and I'm going to struggle to find the right window here, so bear with me. I'm just going to minimize that instead. Might be easier. Apologies. Too many windows all at the same time. So what I'm going to do is go to this one over here, slideshow from current slide. And of course, the display settings end up the wrong way around, so I'll just switch those back. And I'm going to leave us with this link here. So covering everything that we've done today, just a quick summary of what we've covered. We've talked about the ACE certified container platform. We've seen some architecture diagrams of that. We've seen a pipeline in action, being able to deploy across all of the ACE form factors. And understandably, therefore, there's quite a lot of material that you might want to go onto and read. So, and we've compiled quite a nice list here in a blog series. We'll make sure that the PowerPoint is distributed as PDF to everybody that's online today. And hopefully that will answer any questions. I'm just going to ask Rob whether anybody has put anything in the chat that he would like us to address before we close up. I think we've got 3 minutes before folks will need to exit the meeting. So are there any outstanding questions that we need to cover, Rob?
I think there's one that's just come in, which is around if you have several environments, for example, user acceptance and prod, can you develop or deploy to those environments at different times? Can they be split up? And I think, as per your demo, yes, you can deploy. You could orchestrate it in any way, really. You could decide to deploy to all of your develop environments first, make sure that that's all working, and then at a later point you could then orchestrate exactly the same bar file, see where Ben had that stored, it's in Git, it's now a fixed version, a fixed application. Once everyone has said yes, that's great, then that could be promoted into the various environments with the appropriate gates and testing at each level. So I think that was the only one that literally just come in at the end there.
Fantastic. In that case, then, I suspect we will just leave you by saying thank you very much. We'll finish on time. If there are any questions that you didn't get a chance for, please do join our office hours session later, where hopefully we'll be able to see your lovely faces and hear you audibly as well, rather than relying on the chat function. And with that, we'll sign off. So thank you very much.
Cheers.